Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions for Codeforces round 828, which was rated for division 3, and we are going to discuss the solutions till problem even. So let us quickly start with the first question. Now the first question is number replacement, and it says that we have been given an integer array of size n. Now that particular array can be transformed into an array of lowercase English letters using the following procedures. So we choose any number x from the array and we choose any alphabet of the English alphabets. Like out of 26 characters, we just choose one of them and we replace all the occurrences of x with that particular chosen letter, right? So here's given some example. So basically there will be some numbers, and if we choose any one of those numbers, we have to replace that all of the occurrences of that particular number with some other character that is being chosen by us. Now we have been given like two inputs. The first one is an array of size n and the second one is a string. So we have to tell whether this particular array can be converted into this string or not. So for this particular thing, we just have to take care of this particular condition, that whenever we choose a number, all of them are replaced by the same character, right? So in this way, we know that we have only 50 unique numbers. So for all of them, we can store like where they are present in our array. And whenever one of those position changes, all of the characters in the same like which also had the same number should also have the same character in them as well. So let me just give you an example quickly. So we'll take the first sample test case, right? So here we have 2 3 2 4 1 2 3 2 4 1. So what we have to do, if I see this 2 and I see that I'm replacing 2 by C, then all the positions where 2 is present, so 2 is present here and here, I have to make sure that these two positions have C in them, right? Even if one of those, like if 2 was also present here, this position also need to have C. If any other character is present at this particular position, then this is not a valid configuration and the answer would be no, right? So we just have to check for this particular condition whether like that number is present in our array or not, and if it is present, the number of times it is present. For example, if it is present here, here and at the last position, so all of these positions need to have the same character that was in the first position, right? So let me just directly show you the code how this works. So I've taken an integer n and created a vector v of size n. Now I take input in this particular vector and I create a string s and take input in it. So I'm just creating like a double dimensional vector places of size 51. 51 why? Because there will be like 50 unique values from 1 to 50, right? So for all of those values, if they are present in our array, I'll just store all of the indices in which they are present. So for example, if we had this particular example 2 3 2 4 2, so 2 is present at index 0 1 and 2. So at position 2, I'll store like a vector which is 0 0 1 and 2. So this way I'll get my information that 2 is present at these particular indexes. So this is what I am storing in my places vector, right? So places of v of I dot pushback that particular index. So I have all the indexes together. Now I initialize my boolean variable OK with 1. So this would be my answer, right? Now I just run a loop from 1 to less than 51. So for all integers, like for all the unique values from 1 to 50, what I do is, if that particular value is present in my array, right? So if places of I dot size, it means that the size is not 0 and but that particular integer is present in my array, I just store the first character. So I can find it as, so I can find the first index of that particular. So for example, this is my places array. So this is my places of 2. So places of 2 is having this particular vector, right? So these are the indices. So whenever I find s of 0, so I'm just accessing places of 2 of 0, I'm accessing the first index where 2 is present. So this is what I have here in places of I, 0. So this is the first index at which I is present. So if I do this and I like at that particular index, if I find the value of s of index, right, I will get the value or the character C which is corresponding to this particular value of I, right? In this case, the value of I is 2 and that particular character is C. So I am just getting the first character and I loop through all the indexes present in that for that particular value of I. So for example, if I was at places of 2, I will go from 0, then 1, and then 2. So for all of these indexes, I'll check whether the character present at this index. Like for once I just checked in 0, then for the next time I'll check in 1. So actually it should be 1, 2, 3, and 4. Right. So the indexes were 2 and 4. After 0, I'll check it 2. So this is index 2. After 2, I'll check it 4. So this is index 4. Right. So this way, I'll check it all in the indexes whether the character present in them is same as the first character or not. If it is not same, I'll just like mark OK as the false, and I'll just break. Now again, if OK is false, I can just break out of the statement, and at the end, I just print. If OK is true, I'll just print yes. Otherwise, I'll print no. So this would be the solution for the first question, and there like might exist some pretty straightforward or simpler solutions, but this is a very good solution for the first question as well. So moving on to the next question, which is even odd increments. Now this is the second question for today's contest, and it says that we have been given n integers and we have to process two types of queries. If the query is of the form 0, xj, then we have to add xj to all the even numbers of the array. If the query is of the form 1, xj, then we have to add the value xj to all the odd elements of the array A, right? So for this particular thing, we just need to have one important observation, that let us assume that there are odd number of, so this is the number of odd elements and this is the number of even elements, right? I have these two variables, right? So whenever there is a query of type 1, and for example, if I have to add x to it, so the total increment in my sum would be equal to x into odd. So odd is the number of odd elements, right? So I'm adding x to all of them, so the total increment would be x into odd. So this is my first observation. Now when I have the query of the first type, the second thing I have to do is when the value of this particular value, the first value is 1, the second thing I have to do is, if the added value x is even and all of those values are odd, then the new value for all of them would still be odd, right? Because even plus odd gives me odd, right? So there will be no change. But if the value x is odd and all of the values that I already had were odd, then they will all change to even values. So whenever the query is of type 1 and x, that is the number that I'm adding to all of them, is odd, then I'll have to change all of those odd numbers to even numbers. So the count of my count of my even numbers would increase by the number of odd numbers, and the count of my odd numbers would become 0, right? Similarly, when I process the queries of type 0, so the first thing I have to do is I have to increment my sum by this particular value, because there are even number of even numbers and each of them is being incremented by x. So if the value x is even, so even plus even would still give me even, so there would be no change, right? But if the given value x is odd, so odd plus even would give me odd, right? So all the new values would be odd. So what I have to do is, if the given input x is odd, then I'll have to change the count of odd by even, right? And the number of even numbers would become 0. So this is the only thing I have to do, and at each stage I have to print my current sum. So let us have a look at the code quickly. So I've taken n and q as input, and I've initialized a vector of size b, and I've taken input in it. So initially I initialize all my variables odd, even, and the sum as 0. Now I traverse the vector. If the current number is odd, I increment the count of odd, else I increment the count of even, and in either of the case I just add the current value to the sum. Now I process my q queries, and for each of the queries x and y, I just take two inputs x and y. So if x is equals to 1, then what I will do is I'll just increment the value of sum by odd into y, and if my y value is odd, then the total sum, like all the odd values, will become even. So I increment even by even plus is equals to odd, and odd will become 0, right? Similarly, for the else part, when the value of x is 0, I just increment my sum by even into y, and if y is odd, then all of my even values will become odd. So I'll increment odd plus is equals to even and set even as 0. So at the end of like the whole processing, I'll just print my sum for each of the queries. So this would be the solution for the second question. Now moving on to the third question for today's contest, which is traffic light. So this particular question says that we have been like given a situation in which there are three possible colors, red, yellow and green. So it says that the traffic lights repeat its color every n seconds, and at the ith second the color is SI. So it's repeating means, let us consider this case R, G, G, R, Y. So if we have this particular case R, G, G, R, Y. So it says that like at second one it is here, then 2, 3, 4 and 5, right? And then after 5 it will again go to the first value, right? So then it will become 6, 7, 8, 9 and so on, right? So this thing will continue. Now we have been like given a particular starting color for and that color can be any color, like that it can be R, G or Y. It can be any of those colors. We have been given a starting color and we have to find like the maximum answer. So we have to find the maximum value of time such that the maximum value of time such that it is guaranteed that we will reach the G value or the green signal, right? So let me just show you an example directly. So if I take this particular example, right? So I am starting from the value R, right? I'm starting for the value R. So if I take this particular R, then after 1 second I'll come at G. So the answer for this particular R would be 1, right? But what if I was starting at this particular R? If I was at this particular R, then after 1 second I would be at 5. Then for the next second I would be at R again, and then for the next second I would be at G, right? So it takes a total of 3 seconds. The maximum of this is 3, and hence the answer for this test case would be 3. So we just have to print the maximum of all of those values because that maximum value guarantees our solution that in this particular amount of time we would definitely reach a G in our string. So since we can always go to the first index after the last index, there's one way to do it. The first way to do it is, after you reach the last index, you can just manually set the index at 1 or 0, whichever indexing you take. You can manually set it to the first position, or we can also do it like we can just concatenate the two strings together, so that this is a similar pattern, right? So after I do this, from Y the next value would be R. So this is same as just going to the first position. So I'll show you how this will help us. So there might be two cases, right? The first one is, for example, we are starting at R. The first case might be there are some elements in between, and then we finally have a G. So this is the first case when we can go to G from here, right? The next case would be there are some values here, there are some values here, and there is G somewhere here and some values here, right? So after, let us name this part 1, part 2, part 3, right? After this particular position I have to go to this position again, right, to get to G. But what I can do is I can just concatenate it together, and again part 1 will be repeated, then G would be repeated, part 2 would be repeated, R, and then part 3. So from here I don't have to change the index, I can just directly go from here to here. So we can just solve it using like concatenating the string 2 times. So whenever I have a string of length 2n, I will always find a G right after the character I have, right? So this is the arrangement part of the question. Now the question is, how do we actually find the answer? What we can easily do is we can just start traversing from the right, and as soon as I find G, then my distance would be 0, right? If I go to G minus 1th position, then the distance would be 1. Then again I will increment the distance by 2. Then again I will increment the distance by 3. Again I will increment, it will be 4. And as soon as I reach my current character R, which is for which I want to find the distance, I'll set it as 5. And again my answer would now be maximum of answer comma current distance, which is 5 in this case, right? So I can just start traversing from the right, and as soon as I find G, my current distance would be 0, and then I start moving left. So when I'm moving left, I'm just incrementing my current distance by 1 by whenever I take one step. And as soon as I find my character R, for which I need to find the answer, I can update my answer as maximum of answer comma current. Now, what do we have to do this for this particular R? We cannot do anything for this particular R, and for this particular R, we can just set that there is no valid answer for this particular R. We can just set it to minus infinity, right? Because even if we set minus infinity for this, we would eventually get our answer for this particular R, which are both same in this particular case, right? So let me just show you the code. Now I have taken an input n and a character c, right? These are the inputs, and I have taken an input string s, and I just write s as s plus s. So I am concatenating it 2 times, right? So I initialize both of my variables last and answer with minus infinity, right? Now I start my reverse for loop from size s of size minus 1 till greater than minus 1, and I just keep decrementing I, right? Now I increment my last. If s of I is equals to g, so it means we have reached a Gray signal, the value of last will be equal to 0, right? And whenever I reach like the character c which I am finding, I'll update my answer as maximum of answer comma last, right? And whenever I enter the loop, I just increment last at each step. So at the end, I'll just print answer as my final answer. So this will be the solution for the third question. Now moving on to the fourth question for today's contest, which is divisibility by 2 raised to the power n. So this particular question says that we have been given an array of positive integers, and like there are n positive integers. Now we have to make the product of all the numbers in the array divisible by 2 raised to the power n, and the operations that we can perform is we can choose any arbitrary index and replace the value of ai with ai equals to ai multiplied by I. So right, if you're changing an element at index 4, we can change it to ai multiplied by 4, right? And we can like apply that particular operation to a single index only one time, right? So all the selected values should be like different values of index, and at maximum we can choose only n index because there will be n elements, right? So we have to find the smallest number of operations to make the product of all the elements divisible by 2 raised to the power n, right? So this is our task. So the first observation that if I have elements a1, a2, a3, a4, a5 and a6, right? So if I have elements like these, then I have to make the product of all of them divisible by 2 raised to the power 6, right? So it can also be written as 2 into 2 into, so I'll have 2 6 times, and then I'll have some numbers, right? It can be any numbers. So this is 3, 3, this is 2 raised to the power 6, this whole part is 2 raised to the power 6, and there can be any numbers x, y, z here. We don't have to worry about them because all of them together would always be a multiple of 2 raised to the power 6. So we are just multiplying all of those numbers, and we can, like, in one way we can just find the number of 2's present in the factorization of this a1. For example, if a1 is equals to 2 into some value, if a2 is equals to 2 into 2 into some value, if a3 is equals to some value which is not including 2, if a4 is equals to like 2 into some value, a5 is equals to some value which is not equal to 2, and a6 again some value which is not equal to 2, right? So if I am multiplying all of those things, I'll get 1 2 from here, 2 of those from here, and one of it from here. So I'll have something like 2 into 2 into 2 2, right? If I'm multiplying all of them, I'll still have 4 of those 2's, and again I'll have some values which I don't need to worry about, right? So initially I wanted 6 2's, and right now I have 4 of them, right? So I'm still short of 2, like 2 amount of 2's, right? Let me just take it one more so that it is not confusing to speak. So I'm just short of 1 of those 2's, right? I need one more 2 to make it a multiple of 2 raised to the power 6 because currently I have 5 number of 2's. So what I can do is, the operation that I have is I can multiply like each of them with the value of I. So for example, the value of I, here it is 1, here it is 1, here it is 2, here it is 3, here it is 4, it is 5, here it is 6, right? So again, the first value that we have is made up of 2. The second value that we have is made up of 2 into 2. The third value that we have is made up of 2, right? 3 into 2. So if I take and multiply, if I choose the fourth index, I'll gain 2 more 2's. If I choose the second or the third or the sixth index, I'll gain one amount of 2, right? So in this case, I can choose any of them. But if I had this particular thing, if I had 4 number of 2's and I had to choose one of those 3 operation, I would definitely go with this one because it would give me 2 number of 2's and the total number of 2's would be equal to 6. That is 4 plus 2 is equal to 6. Right? So that means we can just like count the number of 2's in the factorization of all the numbers. So this would be the initial number of 2's that I have. So I'll have some initial number of 2's with me. Right? Now I have my target. My target is always equal to n because I want to make the number divisible by 2 raised to the power n. Right? So the next thing is remaining. How many more I need? So the remaining value would be n minus initial, right? So these are the number of 2's I need more, right? So I can just find if I use 2, I can add one more 2 to my answer. If I use 4, I can add 2 more 2's for my answer. Like for example, if I had index 8, then if I use the index 8, then it will help me add 3 amount of 2's to my answer, right? So for all those n from 1 to n, for all the values, I can find the number of 2's which the particular value I can contribute to my answer. So for example, 8 could contribute 3 number of 2's, 4 could contribute 2 number of 2's, and like 6 could contribute 1 number of 2's. So for all of these I between 1 and n, I can find their contribution, right? At the end, what I can do is I can just sort it, right? For example, let us take it 1, 2, 3, 4, 5, 6, 7 and 8. So this will have contribution 1, this will have contribution 2, this will have contribution 1 and this will have contribution 3. So I can just sort their contribution, right? For example, if I needed 5 number of 2's in my answer more, so what I could have done is I could have taken 3 from here and then I could have taken 2 from here, right? If I needed 6, I could have taken 3 from here, then 2 from here, then 1 from here. If I needed 4, I could have taken 3 from here and I could have taken 2 from here. It would be equal to 5 and 4 is less than 5, then I can obviously take it, right? So what I am essentially doing is I can just run a loop from starting to end, and as soon as the value of my sum, that is I am like adding these elements from the starting, if it is greater than equal to the remaining, then I have satisfied my condition and I can just break out of the loop and I can just count how many elements I have taken till now, right? So this particular approach would definitely work because we are just like pre-computing it once per test case and it will work in O of n time. So this approach would definitely work, but there is one more approach using binary search. If you don't want to do this, what you can do is you can just calculate the prefix sums and it would be 3, 5, 6 and 7. So this way you have calculated the prefix sum, right? So you can just binary search on the answer like the particular value which is greater than or equal to the remaining value. So even if you do linearly, it would work, but I did it with binary search during the contest. So you can choose either of the ways. They both would work, O of n and log n, right? So this is the code for this particular question. Now I initialize my vector of size n and take it integrated, and I initialize my count is equal to 0. So I am creating a generating vector. So this particular vector will have the contribution of elements from I to n, right? So I am taking the ith element in a temporary variable t, and so cc would be the current contribution that the element will have, right? So while t mod 2 is equal to 0, while the current number is divisible by 0, I increment cc, that is the current contribution, and I divide t by 2. Now I just push back the final value of cc into my generating vector. So I just sort the particular vector and using reverse order. So ref sort int is my custom function that I have created somewhere here. So this is my custom function in which is just returning a boolean value a is greater than b. So it will help me sort my vector in reverse order, right? So in this particular loop, I am just creating the prefix sums of my generating vector for using binary search, right? So now comes the part where I count the number of 2's which are initially present in my given vector. So again, I do the same. while v of I mod 2 is equal to 0, I increment my count and divide v of I by 2. Now I'll just check the what are the remaining number of 2's which I need more, so it would be equal to n minus count. So if n is less than equal to count, if the number of remaining 2's, if the number of 2's that are present in my current array is already greater than or equal to n, then the answer would be 0 because I don't need to take any of them again, right? If the maximum number of 2's that I can contribute using all of my values in the generating vector, if it is less than the remaining number of 2's that I need more, then the answer would be -1, right? Obviously. And when I come in the else part, so this is just basic binary search stuff. I just check whether it is possible to do it using one element, then I just print it. Otherwise, I just say that it is never possible. So I'm just maintaining invariance that this is always false and this is always true. So how do I conclude that this is always true and this is always false? Because I just check this particular condition. So if it is possible at this particular point, then this should always be possible. And I just check this particular condition. So this gen of 0 was not greater than equal to remaining. That is the only reason I came here. So it means that for L is equal to 0, that the value of gen of L is not satisfying the remaining constraint, and hence it is always false. And then I just do simple binary search and I just print h plus 1, because if I am at the h index, then for example indexing are from 0, if I am at this particular position, I would have taken 3 plus 4, 3 plus 1, that is 4 number of elements. So this is why I am printing h plus 1. So this would be my answer, final answer, and this is how I can solve the fourth question for today's contest. Now the last part where I am just doing binary search, you can also do it using a for loop. Both of them are equally correct and both of them would run under the time constraint, right? So moving on to the last question for today's video, that is divisible numbers, and we are going to discuss the easy version of this particular problem. So the easy version says that we have been given 4 positive integers a, b, c and d, where a is less than c and b is less than d. Now here are some given constraint that x is present. So let me just write it down so that it is more easier and more readable. So we have been given 4 integers like this, and we have a number x. So x is present in this particular range, or x is present in the open interval a and close interval c, and y is present in this particular range. So it can also be represented as b comma d, open and close intervals respectively, right? So we have to find some pairs of x and y such that a particular condition is satisfied, and that condition is x into y is divisible by a into b. So this particular value should be divisible by a into b. So this particular mod value should be equal to 0, right? So this is what our question says, right? At x into y should be divisible by a to b. So what we can do is, we can just first of all find out the product that we are going to need. So I just initialize my product with a into b. And since for the easy version the constraints are small, that all of those numbers are up to 10 raised to the power 5, we can just run a loop for all the values between a and c. So obviously the first element of the pair would be coming from this particular range. So I can just traverse through all the values between a and c. So for example, if I get the value I, right, I have got some value I which is between, let us just take it x. So I've got some value x which is between a and c, which is excluding a and including c, obviously, right? So I need to find some multiple such that this whole thing is divisible by the value of product, right? So how do I find this thing multiple, right? How do I find this value? So I can just check whether what is the next multiple of, or I can just find the LCM of x and product. So if I find the LCM and x and product, if I just find the LCM of x and product, that means it will give me some value y. Now let us just take it. It will give me some value LCM, right? So this LCM is divisible by both x and product. So how will it help me? if I find the LCM of both of those values, now if I try to find this particular value multiple, then this value would always be an integer. So if I didn't take care of this particular condition, if I didn't calculate the LCM, then this particular value multiple would like in some cases it could not be an integer. For example, if I take the product to be 15 and the value of x to be 4, right? If I divide 15 by 4 and I try to find the value of multiple, then it would give me 3.75, right? So this is not a good value. But if I find the value 60, which is the the GCD of both of those values, and then divided by 4, so now it would give me some answer that is 12, right? So it is an integer value. So I have to find integers value of this element multiple, and I need to check whether this multiple is present in the range B, D, right? So I just have to check this. So the first and the foremost condition is that this second value that I am trying to find, or I can take it as y, this y should be an integer. So for y to exist as an integer, I need to find the new product is the LCM of x comma the initial product which I calculated, which is a into b. So as soon as I find this new product, I can just find the value of y as, so y is the element I want to take, so it should be equals to new product divided by x, right? So as soon as I find y, I want to make sure that y exists in this particular range, or some multiple of y exists in this particular range. Why I am saying some multiple of y? If I have taken x and if I have taken y, if they both are equal to some product, right, then some multiple of this particular number, for example, if I take a number q, then some number of this particular number would also be a multiple of this particular number, like multiplying q by both sides, on both sides, right? So either y should be present in this particular range, or some multiple of y should be present in this particular range, right? So what I'm essentially doing is I can take it as this particular range, or I can just mark it as close interval this, right? So I have to find the minimum number such that it is a multiple of y and it is also greater than or equal to b plus 1. So I can easily find it as CL value of b plus 1 divided by y into y. So this would be that value, and then I just need to check whether this value is smaller than or equal to d or not. So this way I will find my final answer x and y, right? So let me just show you before showing the code, I'll just revise what I just said, right? So initially I had some value of product a into b, right? And now I'm traversing through all the values of x between a and c, right? So if I choose some value x, and I need to find some integer value y such that it is divisible by product, then I need to change this product to LCM of product and LCM. So the new product would be LCM of x comma product here, right? Now the integer value of y would be equal to new product divided by x, right? Now so I have found something like this: x into y is equals to new product. Now this particular value that I have found y may or may not be present in this particular range, but I have the liberty to take any multiple of y, because if I take any multiple of y, it would be equivalent, because if I multiplied both sides by q, it would still be equivalent, right? And I can take any multiple of y. So what I do is I essentially find the smallest multiple of y such that it is greater than b, and just check if it is less than or equal to d, because we need to satisfy both of the constraints. So if this is true for any of those x which I am traversing between a and c, I'll just print x and y. Otherwise at the end I'll just print -1 for both of those values, right? So here I have taken input for all those 4 values a, b, c and d, and I initialize my product as a into b. So if the product is already equal to 1, right, if it is equal to 1, then I can just print my final answer as a plus 1 and b plus 1. So this is the base case that I have formed. Now I just run a loop from a plus 1 till less than c plus 1, and I find my new product as LCM of the value of I and the GCD of like this is the LCM way to calculate LCM. I'm multiplying both of them and dividing by GCD of both of them. So I have calculated the LCM in new product. Now I have taken x is equals to I. That is the first value. Now the second value would be equals to 2 take, which is equals to new product divided by I or divided by x. They both are the same thing, right? So the value of I that I have to take was essentially, so in this particular part, this is calculating CL of B by A. So B plus 1 by A. So this is also a way of calculating CL, that if you want to calculate CL of two values, so let me just write it here. If you want to calculate CL of B by A, you can calculate it as A plus B minus 1 divided by A, right? So this is exactly what I have done. CL of this would be B by A, right? So if you want to calculate CL of B by A, then you can also write it as A plus B minus 1 divided by A. So this is exactly what I am doing here. I wanted to calculate CL of B plus 1. So this was actually B plus 1 divided by 2 take, right? So I wanted to calculate this. So I'm doing B plus 1 plus 2 take minus 1. So plus 1 minus 1 cancels out each other, and I divide it by 2 take, which is A corresponding here. And then I multiply it with Y, right? So I have found the first multiple of 2 take, which I wanted to take, like 2 take is the number which I want to take. I found the first multiple of 2 take, which is greater than B, right? Now I just check if y is greater than b. So this condition will always be satisfied because I found y in such a way. And the second condition is y should be less than or equal to d. If both of those conditions are satisfied, I just print x and y and just return. Otherwise, after all the loops, if I don't find it, I just print -1 and -1 at the end, and I just, like, this would be my final answer. So this was the solution for the problem even, and I hope you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.